Now that we've learned a ton about functions, how to graph them, what they look like, and how to find their domains, now we're going to do algebra of functions. So we are going to find sums, differences, products, and quotients where we combine functions to obtain new functions. So the first thing you have to learn is sort of the language. So for example, if they write that they want you to find f plus g, now it should be f plus g of x, but sometimes they write f plus g because they get really lazy. What they're wanting to do is add the f of x function plus the g of x function, and they combine them to make a new function, and that new function will include the domains of the original functions, which we'll talk about. They could also ask you to find the difference of two functions. They could ask you to find the product of two functions. In other words, you're going to multiply the two functions together, and they can ask you to find the quotient of two functions. So for example, f of x divided by g of x, where to be extra careful that the g of x cannot equal 0. So let's practice just a couple with a bit of doing the algebra and then putting in some numbers, and then we'll look at a big example at the end. So for this one, what are they asking you to do? Well, it's written as f plus g of x, so they want you to find the sum of the functions. They want you to find the f of x function plus the g of x function. So for this example, the f of x function is defined as x minus 5, and the g of x function is defined as the square root of x minus 3. Now, whenever I substitute in brackets because you want to make sure there's no operation that you need to do, but these brackets aren't actually doing anything. So my new function would be x minus 5 plus the square root of x minus 3, and there's actually nothing I can even do. There's no like terms, there's nothing to simplify, and it's just done. Then what they'll get you to do is find each of the following if it exists. So there's this little caveat here that's getting you to start thinking about domains. If we look at our original functions, if we look at f of x is equal to x minus 5, this is a linear function. So f of x is equal to x minus 5 is linear, and so the domain is negative infinity to infinity, right? There's nothing that you can't subtract 5 from. The g of x function, however, is a radical function or a square root function. And we know that you cannot take the square root of a negative number, so x minus 3 has to be greater than or equal to 0, and x has to be greater than or equal to 3 to infinity. So that if they were to ask you to find f plus g at 6, sometimes you find this combined function first, sometimes you don't. But what they want you to do is plug in x is 6. Now, like I said, you can plug it into this new combined function. So if we have x minus 5 plus the square root of x minus 3, we could plug in x is 6 everywhere there's an x. And what would we get? Well, we've got 6 minus 5 is 1 plus the square root of 3. And that's as far as we could go. That would be f plus g at 6. Now you could have also found that by doing f of x. Oops, sorry, not f at x, f at 6. And plugging 6 into the f of x function and getting 1, and then finding g at 6 by plugging x is 6 into the g of x equation and getting the square root of 3, and then saying f plus g at 6 would just be those two added together. So all they're showing you here is that we can have a combined function, and then they could ask you to do something like put 6 in. So for example, I could plug 6 into this new combined function if I found it, or if I hadn't found this new combined function and they had just asked me to do f plus g at 6, you could find f at 6, g at 6, and add the two together. And regardless, you get the same answer. So now, what if they asked me to do f plus g at 2? Again, I don't care. You can plug it into this new combined function, or you can plug it into the two original functions as you go. But the key thing with this one that I want you to notice is that when we plug in x is 2, so again, I'm going to plug it first into the combined function. It works in this part. I get 2 minus 3 is negative, or 2 minus 5 is negative 3. But then when I go to plug it into the square root, it doesn't really work. It's not in the domain of the function. In fact, I get what's called an imaginary answer, which we haven't talked about yet, so we don't have to go that far. Okay? But you can just say that there is no solution. Or actually even better, because it's not really a solution, you could just say does not exist. Now we knew that because even though the f of x function is fine with it, right? F at, sorry, not 6, 2. Tired, I shouldn't be making a video right now. F at 2 is equal to x minus 5 or 2 minus 5, which is negative 3, which is all good. Because when you go to plug the 2 into the g of x function and we get that square root negative 1, even though the 2 is fine in here, in your combined function, the domain is inclusive of the domains of both of your original functions. So it does not exist because in the g of x function, x had to be greater than or equal to 3. So they just try to trick you like this. So this first set of questions, they don't ask you to find any of the like f plus g of x. They go straight to, hey, can you find f plus g at 6? And what you're supposed to do first off is look at the question and be like, well, should I put 6 in? What are the domains of this function? Will it make it okay or not? So I just want to show you 3 more examples, and then you can try those questions, and then we'll go on to find just, basic f plus g at x, which is really what they want you to do with this. But they get you to do this because they want you to understand the domain portion of it. So for example, if they get you to do a quotient, g over f of x, this is asking you to do the g of x function divided by the f of x function. Now for this one, if you think about the domains, we said that the domain on g was that x had to be greater than or equal to 3, and we said that for the f of x function, the domain was negative infinity to infinity, which is fine. So if we think about these two numbers that they want us to put in, 8 and 5, would we do it? Well, sure, except that as soon as we put a function into the denominator, we know that it also cannot equal 0. So it's going to add an element of a new restriction. So on the next page, when all they ask us to do is find the new composition, or not, algebra functions, and then ask you the domain of it, you use the domains of your original functions, but you also have to be careful if any of them are in their denominator. So for example, with this one, the f or g of x is the square root of x minus 3, right? Square root of x minus 3. And then the f of x function is x minus 5, which if you think about this one, again, the domain for the numerator is going to be that you have to be greater than or equal to 3. But we have a restriction in the denominator because it's in a denominator. X minus 5 cannot equal 0, so x cannot equal 5. So now this is my new function, and I can decide, do I want to plug 8 into this new function or the two separate functions? I'm just going to plug it into this function because I've found it. So for this one, if I plug 8 in for x, I've got 8 minus 3 in the numerator, and then I plug it in for x in the denominator, I get the square root of 5 over 3. Awesome. All good. The next one, though, they want me to put in 5. So should I even do it? Right? I've already stated my domains because I wanted to do it ahead of time and think, should I put it in or not? Now, because it's 5, I'm going to say it does not exist. If I go to put it in, I've got the square root of 5 minus 3, which is all good, but then the denominator, I've got 5 minus 5, which is 0. So I get the square root of 2 over 0, which does not exist. And again, I'd get the same answer if I did them separately. In other words, if I found g at 5, I find f at 5, and then I divide the two, I would get does not exist. All right, go try those first few questions. So again, they kind of go in this weird stage where these first few questions, they're literally just asking you, find g divided by f at 8, find g divided by f at 5, and you choose. You can find your new function first and then plug it into that, or you can just plug numbers in for g, a number in for f, right, of x, and then just divide the two or add the two or subtract the two or whatever it is that they're asking you to do.